In addition to sleep, plastic deformation in some metallic materials can also occur by deformation of mechanical twins of twinning. And now we have another types of boundary that we can consider as a grand boundary, because on both sides, as you can see here, we have some types of materials, but this is special because it preserves the mirror symmetry across the boundary. So plastic deformation in some metallic materials can occur by the formation of mechanical twins or twinning. In addition to sleep, the concept of a twin was a shear force can produce an atomic displacement that across one side of a plane or the twin boundary atoms are located in a mirror image position of atoms on the other side. So how twinning can form? Twinning can form when a shear force produces atomic displacement that causes one side of a plane or twin boundary atoms located in a mirror image position of the other side. As we can see here, in this side we have ABC, and on the other side we have a mirror image of a CBA. So here we have a grand boundary, like we can see in the figure. On both sides of that, what we see is that we have a mirror symmetry. What is interesting is that we have this twin, and then we back to its original lattice. It is preserved after we have a couple of this twin boundary. So what are the difference between slip and twin boundaries? Can you answer that? So we will talk more about that later. So we can say that twinning is a grand boundary with a special condition where the vertical mirror that is common in some crystal is preserved. So what are the differences between twinning and slip? In twinning, it is the cooperative movement of a group of atoms that shift together to produce a twin boundary. On the other hand, slip is a phenomenon where a single row of atom, as we can see here in the figure, is moving, steadily move to the material by breaking and reforming bond. And here are some properties of twinning. It mainly occurs in metals with DCC or HCP crystal structure. One of the three common crystalline structure, DCC, FCC, and HCP. The HCP structure is the most likely to form deformation twin when strained or when we apply force, mainly due to the lack of a slip system. And twinning also occurs at a low temperature and high rates of shear loading or shock loading. It also occurred when there are few present slip system that will restricting the possibility of slip. And finally, twinning also produce a small amount of deformation when compared to slip. So as we can see in the figure, slip and twinning deformation are compared for a single crystal that is subjected to a shear stress. We can see that slip ledges is shown in A here. These two processes differ from each other in several respects. For example, for slip, we can see that the crystallographic orientation above and below the slip plane is the same both before and after deformation. But however, for twinning, there will be reorientation across the twin plane. In addition, slip occurs in a distinct atomic spacing multiples. In addition, slip occurs in a distinct atomic spacing multiples, whereas the atomic displacement for twinning is less than in the atomic separation.